astronomers may have found a new type of object in the Orion Nebula. Serpens is a famous stellar nursery. What if I told you the James Webb Telescope just found something in space that shouldn't exist, and not just one or two but multiple structures like that? 6 massive galaxies were recently discovered by NASA using data released from the James Webb Space Telescope. Scientists are confused because they might just need to rewrite the textbooks. Let's take a look at what they have discovered. Number 1. Massive ancient galaxies. 6 bright red spots of light were discovered by the James Webb Telescope, and these are no ordinary spots. They are actually some of the earliest and largest galaxies ever found, dating back up to 13.3 billion years. These 6 spots were so red that they must have formed just a few 100 million years after the Big Bang. From what scientists previously believed, these structures couldn't even have formed back then. Experts used to think that it took a lot longer for the first stars and galaxies to form, but in reality these ancient galaxies were already massive and bustling with star formation just a few 100 million years after the Big Bang. One of these universe-breaker galaxies is a trillion times more massive than our Sun, and 10 times the size of the Milky Way. That's huge. So in the long run this discovery has somewhat disturbed everyone, because the universe didn't begin like we thought it did, and the dark ages for the universe may not have been so dark after all. Number 2. New finds in exoplanet molecules. For some reason astronomers have been obsessed with finding an exoplanet, and among many candidates there's K2-18b, which has life. Why is that? Well, for one, they found water vapor in its atmosphere, and quite recently the James Webb found carbon-bearing molecules like methane and carbon dioxide. So yes, K2-18b may have a hydrogen-rich atmosphere and water ocean, perfect conditions for life. Wait till I tell you that there was even detection of the compound dimethyl sulfide as well, and guess who produces that on Earth? Just living organisms. I'm sure you're smart enough to connect the dots here. Number 3. Origins of the cosmic web. Astronomers using NASA's James Webb Space Telescope also spotted 10 galaxies arranged like a string, just 830 million years after the Big Bang. That's like finding a childhood picture of this universe. But why is it a big deal? Because these galaxies couldn't even have existed back then from our current understanding. Yeah, it looks like it was pretty inaccurate, wasn't it? Also, this structure is about 3 million light-years long and is anchored by a super bright quasar, which is a galaxy with a giant black hole at its center. And guess what? This line of galaxies might grow into a huge cluster of galaxies like the Coma cluster we know in our neighborhood in the universe. Number 4. Early supermassive black holes. You probably know that black holes actually grow in size by consuming passing stars and clouds of gas and dust. Thanks to James Webb, scientists have now captured supermassive black holes working in the early universe even when they haven't had much time to feast on their surroundings. In fact, it also captured the most distant black hole ever seen in X-rays in a galaxy called UHD-1. The mind-blowing part, UHD-1 is a solid 13.2 billion light-years from Earth, meaning we're watching the black hole as it existed just 470 million years after the Big Bang. This black hole has an estimated mass between 10 million and 100 million times the mass of the Sun, which is downright unbelievable when you consider that it's comparable to the total mass of all the stars in its host galaxy. Number 5. The HSE Head Nebula. This nebula is also known as Barnard 33 and is about 1,300 light-years away. All thanks to the instruments on the Webb telescope, astronomers have been able to see the small-scale structures of the illuminated edge of the HSE head for the very first time. It formed from a collapsing interstellar cloud and gets its glow from being illuminated by a nearby hot star. The gas clouds around the HSE head have mostly dispersed, but the iconic pillar shape is made of dense material that's hanging tough. Astronomers suspect that the HSE head has around 5 million years left before it starts to fade away. Now astronomers can track how dust particles are being swept away from the cloud as they are evaporated by UV light, and then create some really complicated patterns. Number 6. The dust left by a supernova. Then there's Copia A, the aftermath of a star explosion 11,000 light-years away, which happened around 3,140 years ago in the Copia constellation. We can still see its remains today. Astronomers, though, are particularly transfixed by the warm dust, which plays a huge role in forming planets and life. Most of this kind of dust is believed to come from the heavy elements thrown out by supernovae. Because of James Webb, we can now see the tiny fragments of this debris made up of sulfur, oxygen, argon, and neon, all glowing in beautiful orange and light pink hues. The dark gaps you see in the image are caused by those tiny fragments piercing through the gas, leaving a cosmic trail of bullet holes. And as if that's not amazing enough, we can even see light echoes. It's where the original light of the supernova gets absorbed and reprocessed as infrared light by the space stuff around it. Number 7. A star-forming region, Serpents Nebula. Thousands of miles away, then there's the Serpents Nebula, which is about 1,300 light-years from Earth. This area, which covers about 16 trillion miles by 11 trillion miles, is where many young stars are taking their first breaths. NASA's James Webb Space Telescope found many unusual things in this nebula. All thanks to it, they found aligned protostellar outflows, basically jets of gas expelled by newborn stars interacting with the surrounding gas and dust. These outflows are all aligned in the same direction, which has never been seen before. Not to mention, it also brought forward the Bat Shadow, a planet-forming disk that looks like it's flapping. Impressive, isn't it? Number 8. Unseen features in the Milky Way's heart. Not just that, we're getting a lot more information about our galaxy's dense center, all thanks to the James Webb Space Telescope. The telescope's near-infrared camera recently captured the most detailed image of the Sagittarius A region, which is around 300 light-years from the Milky Way's central supermassive black hole. In this image, we can see like 500,000 stars, so it's no surprise that some truly mysterious structures have left astronomers scratching their heads. In talking about some needle-like structures in ionized hydrogen that seem to defy all known patterns, and they are much bigger than the scientific community initially thought them to be. And that's not all. A cluster of protostars, stars that are still in the process of forming and gaining mass, was also spotted. Number 9. Jumbo. If you're into space, I'm sure you've heard of jumbos. No, not the sandwich. I'm talking about Jupiter mass binary objects. They are these wild, free-floating planetary mass binary systems in the Orion Nebula, about 1350 light-years away from us. James Webb found around 40 of these jumbos, and they're like nothing we've ever seen before. Each one has two parts, kind of like a double planet situation, with masses ranging from 0.6 to 14 times that of Jupiter, and they are not tied to any stars, they are just out there on their own. Astronomers use a super-powerful telescope called the Carl G. Jansky Very Large Array to pick up radio waves coming from one of these jumbo systems called Jumbo 24. The radio signals are steady and come from both parts of the binary, and it's honestly quite shocking, because these jumbos shouldn't be able to form or stay together as binary systems. Number 10. Analyzing star formation in depth. Scientists have always been curious about star formation, but stars form in dense clouds of gas and dust, right? Well, usually dust blocks most of the visible light, so we can't see much. But that's where James Webb comes in, as its infrared radiation cuts through that dust and lets us see into all the never-seen-before details. Particularly speaking, there's the Rucci complex, which is only 390 light-years away from us. The telescope captured a frozen-in-time explosion featuring around 50 young stars, many of them about the same mass as our Sun. And if it wasn't for James Webb, you'd be as good as seeing a black image. But what blows my mind the most is that the telescope's images have also captured dozens of young low-mass stars, along with the high-speed streams of gas and particles they emit, lighting up surrounding clouds of molecular hydrogen. Number 11. Circles of the Ring Nebula. Then there's the Ring Nebula, also known as M57, in the Lyra constellation. We all know it's one of the coolest planetary nebulae out there, and it's not too far from us, only about 2,500 light-years away. But the James Webb Telescope has truly blown everyone's minds by revealing some awesome details about this nebula. The ring itself is made up of about 20,000 clumps of molecular hydrogen, and the inner region is filled with super hot gas. The main shell has this thin ring of carbon-based molecules called polycyclic aromatic hydrocarbons. That's a mouthful, but it just means that there's a ring of enhanced emission from these molecules in there. What sets M57 apart from other nebulae is that it has an interior morphology that looks like a flower blossom, and it seems like Webb caught it at a rare moment in time when it had a bright star caught inside, making this nebula truly unique. The James Webb Space Telescope is truly breaking boundaries in space science. And now, thanks to its astonishing imaging and analysis capabilities, we're gaining a whole new understanding of the universe and its history. In the meantime, it might just be time to throw away some old textbooks.